to solve a trig equation, it's kind of like solving an equation for, x or y. Just a couple little extra pieces we have to consider. Okay, so like sine theta minus 1 equals 0. So if you treat sine theta like the x, like the variable, okay, we would add 1 to both sides to get it by itself, right? So you get sine theta equals 1. Okay, so a trick with sine and cosine is that you can think of sine as the y coordinates and cosine as the x coordinates on the unit circle. Okay, so like this dot on the unit circle is 1 comma 0 because it's 1 unit away from the origin. So cosine of 0 degrees of no rotation would be 1. Sine of 0 degrees would be 0. And then if you rotate yourself 90 degrees, this is 0 comma 1. So that means cosine is 0 because it's cosine's the x coordinate, and sine would be 1. Okay, so that's what we wanted. We wanted sine to equal 1. So we just found out sine theta equals 1 when we're at a 90-degree rotation, which is pi over 2 in radians. Okay, so theta, to make this equation be true, is pi over 2. But there's also an infinite amount of solutions. Okay, if you got pi over 2, you could do a whole 360 rotation. Okay, so if you add 2 pi to it, that's another solution, right? Because here's pi over 2. 2 pi is a rotation, so that's also true. And then another 2 pi is also true. So we're going to add 2 pi and then a letter k, where k is an element of the set of integers. That's shorthand for saying k is an integer. Okay, because it could be plus 2 pi, plus 4 pi, plus 6 pi. That'd be 6 pi would be 3 rotations, etc., etc. So this is the full solution. I don't think they need us to get common denominators or anything like that. Let's try typing in pi over 2 plus 2 pi k, where k is an element of the integers. Oh, what did I do wrong? Right radians and use the OR button as necessary. Oh, I got an extra pi. There we go. Just typed in an extra pi there. So same thing with this next type of one. Let me see if there's another one. That one's really similar. And this one's a little different. So let me do this one real quick. So we got tangent theta plus square root of 3 equals 0. So again, try to get tangent theta by itself. Tangent theta equals negative square root of 3. And then think about the trig ratios that we've practiced that make tangent theta equal negative square root of 3. So think about just one triangle. So here, all are positive here. Sine's positive here. Cosine's positive here. Oh, sorry, tangent's positive there. And cosine's positive here. So tangent would be negative in this quadrant and in this quadrant. Okay, so a triangle that would make this happen would be if you had a 1/2 ratio and a square root of 3 over 2 ratio. Those are the ones that we keep using, right? Because if you have a triangle like this, 1/2 square root of 3 over 2 and then 1, the angles that correspond with 1/2 is always 30 degrees. The angle that corresponds with square root of 3 over 2, that's always 60, right? So we can wrap this up, because tangent is the opposite divided by the adjacent. Oops, I think I actually have it backwards, because look, 1/2 times 2 over square root of 3. When you flip and multiply, that's going to give you 1 over square root of 3, which is... No, I've got it. Okay, this is right. Okay, so I was jumping over that too fast. So tangent is the opposite of your angle, so opposite of the reference angle, divided by the adjacent of the reference angle. So opposite's 1/2, and then the adjacent side was square root of 3 over 2. So I got to flip that second fraction and multiply. Oops, that's a square root of 3. Okay, and then the 2's cross cancel, so you get 1 over square root of 3, and it's also negative, we should know, because look, that's a negative square root of 3 over 2 times a positive 1/2, which is, if you multiply the top and the bottom by square root of 3, that's negative square root of 3 over 3. Shoot, yeah, sorry, this is backwards. Look, because that's negative square root of 3 over 3 isn't the same thing as negative square root of 3. Let me see. I don't think there's the other way of doing it. If you flip, what I was wondering about doing in the first place is if you flip 1/2 and square root of 3 over 2, that might be the angle we need. So that would no longer be 30 if we flip those. If that's square root of 3 over 2, and if that's 1/2, then the opposite divided by the adjacent. Yeah, sorry, I did have it backwards in the first place. Because now if you flip and multiply that second fraction, that makes square root of 3, and that's better, okay? Because that's a negative 1/2, so that's a negative 1/2. So this makes negative square. Okay, so I just had the triangle backwards there. But that makes this 60 degrees. Okay, so the reference angle, we got 90, and then plus another 30 degrees, so to make a full 90 degrees here. So 90 plus 30, that's a 120 degree angle. So the theta that makes this equal negative square root of 3, theta equals 120 degrees. But then there's another one. You can go from 0 to 90 to 180 to 270, but then plus another 30 degrees because this triangle is the same thing, right? So that lands you, let's see, 90, 180, 240 plus another 30 makes 270, right? 180. What am I missing here? Oh no, that's 270 here, so that's 300. The other theta in degrees is 300. Okay, so those are the two unique solutions in one full revolution of the circle. But then we also need to put it in terms of radians, they said. So 100. My quick way of putting things in radians is take the degree, divide by 180, stick a pi on there. So that's 2 pi over 3 when you simplify. Okay, so 120 is 2 pi over 3. And then 300, if you do the same trick, 300 divided by 180, that's 5 pi over 3. Okay, so those are the two angles that work. Okay, so let's plug those in like we did last time. 2 pi over 3, and then plus that 2 pi. Oh, it says, oh good, it says just on the interval 0 to 2 pi. So for this one, we don't have to make the full, we don't have to express the infinite amount of solutions, just the ones within one revolution of a circle. So I click this button to get me two answers. I've got 2 pi over 3, and then the other one we found was 5 pi over 3. Okay.